All right, good morning, everybody.
Good morning.
Welcome to Texas Camp. Everybody's doing good, I hope. Everybody got some tacos in their belly?
Did you hit the button?
I did hit the button. The red light is on. Howdy, my name is Dustin Younse. I am a software engineer for Acquia. We're a small hosting company based out of Boston. You might have heard of us.
And I'm Rob Ristroph. I'm a technical architect and sometimes lead developer or other roles on the professional services side of Acquia. So I work on a lot of mostly big corporate websites type projects.
And this is Become a Better Developer with Debugging. This is going to be our...
So I noticed out in the audience there's a lot of people there's a handful of people who've maybe seen versions of this talk before, and there's definitely a lot of people who are good developers, and a lot of becoming a better debugger is just experience and other people's experience. So, and a lot of reasons why this talk is great is because of the war stories that come out. People tell great stories. So if you, as we go through it, like you might think of any cool debugging war stories, and maybe they become more cool after time. And for the Q&A session, like there's always some great stuff that comes off of that. So just keep that in mind.
And keep it in the front of your mind, because the person with the best war story gets to walk away with this most excellent debugging book.
Would that be true?
What? We'll know if it's not. So this is our outline. We're going to walk through a couple things. Number one, what is a bug? What is debugging? Why should we care? What is a scientific method approach? Some tools and some other tricks. At the very end, we've got some links for some further reading. So if you see something on the screen, you don't necessarily have to write it down. We'll probably have a link for it. And we'll make these slides available afterwards. So the first big question is, what is a bug? And I think we've come up with the idea, when your mental model of the situation, the code, the website, doesn't match the actual behavior. That's what we're going to call a bug. You probably tried to do one thing and it's doing something else, and you're trying to figure out why. And believe it or not, in the average career, most of the bugs you work on are going to be your own.
Yes, so if there's just a feature missing, like the block's on the wrong side of the page, you don't know why it's there because you haven't moved over there yet. Like, that's not a bug, that's just somebody complaining a feature needs to be implemented. The frustrating thing about bugs is when you have this idea of where things should be, and that's not what's coming up on the screen. And one of the most annoying things about it is, unlike just developing a feature, it's incredibly hard to estimate how long it's going to take you to figure it out. And so it's definitely one of the more frustrating aspects of our existence.
Before we get into the meat of things, we have to take a moment and recognize nobody's perfect. Nobody in here has ever written perfect code. Even my boss Dries does not write perfect code. You may have noticed. So last summer, this came up. Glitch. They're like an online Node.js like hosting play around kind of thing, where you can go spin up an application, play with it. And their Twitter account asked this question. So they're like, my code, it once took down a client's intranet mid-demo. What's the worst thing that you've ever done? Here we've got Zach Holman. He was one of the early employees of GitHub. He wrote a lot of their code. He once shipped GitHub to production in development mode. That was pretty neat. I'm sure that had some great performance implications. Jen Schiffer, she's a JavaScript developer. She now works for Glitch. She used to work for the NBA. She once took down the entire Chinese NBA site when she was just trying to change the name of the team. This is my all-time favorite. The first client patch this person wrote caused all the W-2s to print with the deceased box checked. It was a nunnery. She killed an entire nunnery. And of course, I can't leave myself out because nobody's perfect. I used to work for the UT libraries, and on my first day back from Christmas break, I took down the entire website with a botched FTP transfer because it truncated the htaccess file. That was super fun. didn't know how to find the backups, didn't know how to restore the backups. Turns out I didn't have access to restore the backups, so it turned into a whole morning of fun. So you just keep in mind, nobody's perfect. You're always going to make mistakes. Other people are going to make mistakes. That's just how this stuff goes. And you just need to learn how to deal with it. So, what is debugging versus what you might usually just call troubleshooting? So when we talk about mental models, and you're talking about Drupal, this is often the basic mental model of Drupal. It's just a featureless black box. Stuff goes in, stuff comes out, but you don't really know how or why. I've been working on Drupal, I think it's 10, maybe 11 years now, and I've got a pretty advanced knowledge of Drupal, and this is now my mental model of Drupal. Still a black box, but now I have a status light, and I can recognize that, yes, indeed, it is Drupal. So this is the idea. Like your mental model, you have to have that. You have to be able to wrap your head around what is actually happening inside of that box. And that's some of the stuff that we're going to talk about. But first, we have a brief digression. This is my personal thing that I like to talk about. Who has read the book Maniac McGee? Anybody? All right, we got one in the back. If you haven't read this book, you should read this book. It's really great. It's very short. It's a child's book about a kid who goes by the name Maniac McGee. He is a boy genius when it comes to untangling knots. That's like his superpower. He can untangle any knot. So he becomes famous in amongst his peers for the ability to untangle knots. People bring him their yo-yos, their shoes, whatever it is that has a knot. It seems like he just snaps his fingers and they untangle. One day, he's told about Cobble's knot. This is the largest, gnarliest, grossest knot you've ever seen that is hanging on a flagpole outside of a pizza parlor. And the owner of the pizza parlor has said, whomever can untangle this knot gets free pizza for an entire year. And I mean, for a kid, that's gold. Can you imagine having free pizza for a year? So his friends take him there, and they're like, oh, he's just going to walk up to it, he's going to look at it twice, snap his fingers, it's going to fall apart. He's magic. Of course he can do that. But instead what he does is he sits down on the picnic table next to the flagpole, and he just stares at the knot. And he spends an entire day just looking at it. He gets up, he walks over to it, he walks around it, he kind of pokes at it. He's trying to build his mental model of this knot. He's trying to figure out the ins, the outs. And it's a flagpole, it's a piece of rope. It has a beginning, it has an end, it has this knot in the middle. So basically like a website. And of course his friends, he doesn't do it instantly, so they get kind of frustrated, kind of bored. They walk away. The next day they come back to surely today he's going to get it. And he does. And it's great, and everybody gets pizza. And so this obviously is a metaphor for a basic mental model of Drupal. So now we'll get back to that. Here's a fun knot. On the right, you have a small part of the render functions that involve printing stuff out on a page in Drupal 7. On the left, you have the same thing in Drupal 8. So again, we're seeing lots of ins, lots of outs, but it's a flowchart. So we know that it has an in point and an out point. And this is what we have to start wrapping our heads around when we're debugging a problem. We have to start to realize that it's not magic, it's not a black box. It's literally just a series of functions doing stuff. Now we have another brief divergence on origin.
And so when I first started doing talks and debugging, I tried to hunt down the urban legend for the origin of the word bug and so on. This picture I think is from Wikipedia. It's an engineer's notes from the ENIAC running in Boston. You see his timestamps on the side, and he has started a cosine tape. He's running off paper tape at the time, and he has problems. And then he finds a moth stuck in a relay, and then he writes here, first actual case of bug being found. And that's often quoted as the origin or whatever. But he wouldn't have put the word actual there if the word bug wasn't already being used like that. And if you dig around, you can find plenty of references sometimes in stuff from people working on complex systems in World War II where they use the word bug sometimes used the word gremlin more often back then, and Thomas Edison used analogies to insects to problems. I think he used gnat, not bug. Anyway, like if anybody ever like happens across like older references to using the word bug in that context, that'd be cool. I don't know where it actually came from. John?
What about the apocryphal story of Grace Hopper being the first one that coined the use of the word?
Grace Hopper was the boss of the man writing this stuff, and she was probably physically there. And so she would make reference to this incident when she gave talks.
Hence the mob, got it.
Mm-hmm. It's like Grace Hopper was, for those who don't know, early and seminal computer scientists working for the Navy who did a lot of their computation machines.
COBOL.
Yeah. And anyway, she was in charge of this facility at the time this was having down. They found it, so the guy even got to leave by 5. You know? that was unusual. It never happened like that again.
All right, so we talked about rope, we talked about bugs, we talked about pizza. What's debugging? We still haven't got there. So like we mentioned earlier, debugging it's the process of making your mental model of the issue match reality. Understanding why the bug happened is different from and often more important than just fixing it. And I think, to me, that is the primary difference between debugging and troubleshooting. A lot of times when you're troubleshooting, you're just trying to fix the thing. When you're debugging, you're trying to find the actual underlying cause, so hopefully you can prevent it from happening in the future.
So cause versus symptom thing.
Yes.
Yeah, and there's a phase of debugging where you're just trying to figure out what to do. And then once you understand what's going on, the last part of actually fixing it is usually not that much different from, implementing a feature when you totally understand everything that's going. It's the first phase that's the most frustrating, and often people aren't aware of how to do it. It's very hard to estimate, which often, like any kind of team environment, just leads to a lot of problems. Like people instantly start trying to figure out how to just work around and cover up the bug just to keep themselves on schedule. And in really complex systems, you may spend, if you actually look at where you spend your day on a kind of a big integrated team, you may spend a third of your day on just kind of bureaucracy, for lack of a great term, pointing tickets and meeting with the client and stuff like that, and maybe if you're lucky, a third of your day doing actual programming and getting stuff done, and a third of your day doing something else. And if you actually look at what you're doing all the time, and throw out all that Reddit, Facebook, and everything, you actually spend a lot of your time debugging that is sort of unaccounted for. And if you kind of mentally lump that in with all the other technical stuff, then you tend not to get better at it. But if you think of yourself as going into a debugging mode versus going to programming mode, it's one of the things that helps you get better at debugging fast.
Yeah, it'll just take 10 minutes. I'll knock that out. It's fine. And so again, why is debugging important? So here we have a quote from Maurice Wilkes, who developed the first stored program computer. As soon as we started programming, we found to our surprise it wasn't as easy to get programs right as we had thought. Famous words. Debugging had to be discovered. I mean, imagine that. It's kind of crazy to think about a time when computers were a thing that they were like this natural force almost, that you had to figure out all the rules to before you actually do stuff. And now we put cats on the internet.
Yeah, and so Maurice Wilkes was part of the team that did some of the computer stuff for breaking German codes. This is after the war, when they were starting to build the first of some of the bigger things in Britain. And in his little, and there was a brief point in time where probably most of the actual code written in the world was written by him. But in his book, he describes how they had a computer in the basement of this old English country house. His office was up on a higher floor, and he'd work and run down these spiral stairs and load up his stuff, and then like something wouldn't work, and he'd go back up to his desk. And he said he was like running up and down that stairs like repeatedly, and he said he was rounding a corner on the landing once, but like he just had this epiphany that he was going to spend the rest of his life finding problems that he created for himself.
So why is debugging important? Number one, you do it more than you realize. Debugging isn't just sitting down with a debugger and a notebook and getting very into it. Debugging is anytime you write a line of code and you hit refresh and it doesn't do the thing that you thought it would do. Anytime you open up Chrome developer tools, that's debugging. So it's important to kind of learn the holistic approach to it, so you can do it a little bit more efficiently. Of course, it's a source of much uncertainty. I think anybody here work for an agency? Anybody here do hourly work? Have to estimate your work? Yeah, this is the trick, right? Take your estimate, double it, add 20%. Does that sound right?
200.
It's the perfect number.
Take 5 minutes.
Just 5 minutes.
Yeah, and usually in debugging, there's not very good milestones along the way. So you're working on something for 2 days, and it's, well, how far did you get? And you don't know. Like you just said, well, I eliminated a lot of common things. That's not very fulfilling to people usually.
Very close.
Yeah, I know what it's not. I definitely know that. So it's good to think of it as a distinct thought process or skill, and it's good to develop it in that way, so you can become more gooder and more efficient at it. So here we have what we're calling the scientific method of debugging. First step, observe, collect data as much as you can. Again, we're not trying to fix the immediate problem. We're trying to fix the underlying bug. So we need to know what causes it. Is it a certain browser if it's a front-end issue? Is it a time of day if it's a server load issue? There's all types of surrounding data that maybe doesn't seem important, but maybe it is. I've been running, I don't know about you, but I've been running JavaScript blockers more and more lately in my browsers. And they do some real funky things to a lot of websites. Oh no!
See?
Yeah. So if you're getting a report from an internal person, and you can actually get access to their computer to see okay, show me exactly what you're doing, and then okay, what extensions do you have installed in your browser? Are you on Wi-Fi? Are you tethering to your phone? All these types of things can help you figure out some of these issues. And from that, you want to make your testable hypothesis, which is a change to your mental model, because your mental model says it should work one way. It's obviously working a different way. So now you have to come up with the hypothesis as to why. Then you're going to collect your data from the test, which is changing a line of code, changing a configuration, and then you're going to adjust your understanding of the model based on that data, and then you're going to repeat that over and over and over again until you get it right. The most important thing here is when you're making a change to one of the, you're making a code change or a variable change, do one thing at a time. Know what that one thing was, and then when it doesn't work, undo that thing and try the next thing. As you're getting sucked down these rabbit holes, when you're getting frustrated at the code, it's really easy to do 19 different things, and then magically it started working. But now you don't know which of those 19 things actually fixed it. Maybe it was a weird combination of 2 or 3 of them, but without separating them out, it's hard to start figuring that kind of thing out. Yes?
So what about the necessary but not sufficient? In other words, you try one thing and then it in and of itself doesn't work, but it's needed along with something else you find.
That's the rabbit hole. Yeah. I mean, yeah.
A lot of that testable hypothesis stuff, often you can't guess the final thing. The best you can do with a testable hypothesis is divide and conquer. So you can say that I think this problem happens only for logged in users, and then you can couple little tests. And now you haven't solved it; you just narrowed it down. Or you can say I think this problem is somehow encoded into the prod database, but if I do a fresh install and create some test data, it won't be there. So those are testable hypotheses. A lot of the trick to debugging is, the gut feeling and art to it comes to picking hypotheses reasonably. So they give you a lot of trimming of your problem space, but they're also quick to test. So like if you have a hypothesis that's a cosmic ray changed a bit in the RAM on the server, that's hard to test, right? It doesn't give you much. So it's maybe excuse for a couple of weeks or something. And so a lot of the art of being able to debug fast consists of sort of picking these things that you can test them fast and like eliminate big swaths and focus.
You ever told that to a client?
Cosmic ray.
It didn't work.
You can always blame it on internet traffic. That usually works with clients.
Yes, it's always the amount.
Yeah, there's plenty of websites out there with pretty maps that you can show them with some red blotches. Yeah, it's internet traffic. Don't worry about it. So what does this look like in real life? Uh-oh, something's broken. Freak out, right? Yeah. Oh my God, your client's on the phone, your boss is standing over your desk. Something is broken that has to be fixed right away, immediately, absolutely. Why wasn't it already fixed? I'm standing here looking at you. Why haven't you fixed this problem yet?
The first phrase is everything is broken.
Everything
is
is broken.
Something is broken. Nothing works.
So, step one, relax. It's okay, I promise. I really do. I love this quote from DHH. He's the guy who created Ruby on Rails all those years ago. Unless you're making software for rockets, self-driving cars, or pacemakers, let's ease off on the mission-critical bullshit, yeah? Does anybody here work nuclear weapons? Okay, we'll have to talk later. Self-driving cars, TELUS robotic surgery.
Drupal powering any of that's scary.
Yes, it is. Yeah.
I would throw in identity-related stuff, thanks to Equifax and Yahoo.
But yeah, so the moral of the story is most of us, we work on websites. Even like the most critical website, if it's down, you're going to lose money. Sure, that's like the worst case is like you can't collect sales for a while. Unless you're Amazon, you don't really measure that in seconds. But it can cost you a lot more than that if you rush into a fix that makes it worse, or you rush into a fix that makes it recur again and again. So it behooves you to just relax, realize that the world is not ending, and just take a minute, think about the not. Remember this is a solvable issue. There's an in, there's an out. You just have to figure out what's going on in the middle. So take the time that you can to just analyze the problem, think about the problem, think it through. Find context. So I'm working at Acquia now. One of the things that I wasn't prepared for, but has been really nice, is we have an enormous Jira ticket system. Every department has a Jira system. For the most part, they're open to everybody. And we get the historical, like teams that don't exist anymore. You can still find their tickets. So you can go to Jira and you can search for something across the entire company, the entire history of the company, and see if this type of problem has come up before. And that's super helpful and super nice. I can go into the Acquia GitHub organization, and I can search for pieces of code across the entire organization and see, they're using this same piece of code over here. Let's see how they did it and see if my approach is any different. So it's really great to gather all of the context that you can before you dive into the problem. So you have to figure out. So somebody's telling you everything is broken, and then yes, the next thing you have to figure out is something is broken. Some very common Drupal type things is something not showing up that is supposed to show up. Is it new content? Have they actually published it? I can't tell you the number of times I've had a client freak out because they left it as a draft and didn't publish it. Is it a front-end cache? As you get into bigger and bigger websites, you get more and more layers of caching. There's all kinds of weird stuff that can happen there. Is it old content? Maybe it's an old content type, and maybe the permissions aren't set properly, so anonymous users aren't able to see that old content. Has something changed recently? That's one of the most important things you can ask yourself. Drupal makes it tricky because a lot of our changes live in the database, which isn't easily diffable. But there are workarounds for that. Is something showing up that shouldn't? raw HTML and JavaScript being dumped out of a WYSIWYG field. That's, as you hand open WYSIWYG boxes to random people at random companies, they start dumping in a lot of really weird stuff. All that Microsoft Word cruft and all kinds of fun stuff.
So at this stage when you're sort of like defining the problem, this is also a point where like it may not be as appreciated as well. Like maybe you can make a connection to Nikki's comment about the attribution thing on Drupal or whatever. But often at this point, the non-technical manager or whoever has the closest touch with the client can have a big role here. And you can have somebody who's kind of a project manager who actually can save like massive, like tens of thousands of dollars worth of money by asking like a few key questions like very early when bugs get reported. So I've worked with some people in that role who one good habit they had is like whenever they were working with a customer who was the UAT person, they would like find out what computer they used and look up how to take screenshots and like train them to take a screenshot and attach it to an email and send it. Sometimes they had to train them how to do basic things like attach the file to an email. But get that key combination down that will snap a screenshot, and then you end up getting these screenshot bug reports, which inherently have like a bit more context to them. So from the title bar and so on, you can tell if they're not using the same computer they usually use, for instance, and which browser they're using, and all that kind of stuff. There's there's a lot of value to like pulling up a lot of context at this very first stage. And if you're in that role, like you can, like occasionally on big projects, I feel like there's somebody who can like earn their salary for 6 months in like a 5-minute conversation that stops some team from going down a rabbit hole or something.
Yeah, and of course, like more complex behaviors, like workbench moderation. Can we state the exact steps that caused the bug and why it's not what we're expecting?
The more complex thing people are working on, the more likely it is that the person who's saying they're a bug doesn't fully understand what they're doing, and that's can be sort of like a design bug, like the system is not set up well. Like people will always be frustrated with it, not necessarily a software bug.
Yeah. Of course, Drupal is perfectly designed.
Yeah.
For all use cases. So your next step after you know what the problem is to try and replicate it yourself, and that's where user reports are very helpful. One of the worst case scenarios is you make changes, but because you don't know how to replicate it, you have to just wait to see if the customer says if it's still broken or not. So replication can be tedious, but it's extremely valuable for actually understanding the problem and fixing the underlying issue. So you want to observe and think about your user's operating procedure, whether that's screenshots, if you have the ability to screen share with them over video, you can get a lot of good information that way. Because without being able to replicate the bug, you can't actually debug it.
And so sometimes I've been on teams where there was like some bug that kept cropping up, and often they would sort of take some junior member of the team or whatever, and so I'm like, all right, like you work on this, and kind of kick them off in the corner to work on that so they can keep making progress on everything else. And often 99% of the work is just figuring out how to replicate it. Like once they can make it happen every time, people like Earl said, oh, just the fact of how you make it happen every time, it's instantly clear what's going on. Another reason why performance and load-based bugs like have a general reputation for being hard is that most developers don't know or don't have all the resources available to replicate them. And so and that's also true with cache-based bugs, because usually they require like the sequence of events to recreate them requires filling the cache or clearing the cache in a certain way or something. So for all of those types of bugs, like learning the tools to do some simple load testing of various types, realizing that a cache-based bug, like your steps to replicate, must be much longer than 3 or 4 clicks, can really help you. And once you can make it happen every time, the rest of that loop of hypothesizing and testing gets really fast because you can test really fast. So you can now afford to like make all kinds of random guesses and see if it fixes it really quickly just because you know how to replicate it.
And I will say we do a lot with Cloudflare, and it's amazing how quickly their support department is able to come up with a solution when you're able to give them steps to replicate. They're really good at just saying, "Oh, that's not on our end. That's not on our end. It's something on your side." But as soon as you can replicate it, they're like, "Oh, I guess you should actually do something." As a former support person, I empathize, but also, come on, guys.
You can make kind of a connection there to test-driven development. So if you could write a test that will replicate a bug, almost surely, like it's not going to be one of those. It's much less likely to be one of those infinite things that takes a lot longer than you expect.
And so, when you're actually working the problem, work from the bottom up. I'm a big fan of log files. You need to know where they are on the systems before you need them. That is the important part. You don't want to be looking for these log files under fire. You want to know where they are. You want to know the passwords you need to get to them. I'm a big fan of a tool called Multitail. It's a Unix, Linux, Mac utility that makes log files actually look decent. But it does some really cool things as well. It lets you do multiple log files on a single screen. So you can interleave, say, your Apache logs and your PHP error logs in the same view. So you can see immediately, oh, this one type of Apache request always gives me a PHP error, which is really nice, really useful, really powerful. And of course, find all the, again, we're just going to keep reiterating, find all the contextual information you can, because you can't really do much until you have that information.
Yeah, I think there's if you're going to be working on a particular system, like with a particular hosting company or with your own local development environment and so on, like if you're in the position where a bug is brought to you and like you're sort of in front of the client when it happens, this sort of thrashing of trying to find various information and the rabbit holes you go down if you pull up the wrong log files and stuff like that, like just makes you look bad. And it also breaks your mental train of thought. Like you're spending a lot of time learning the environment and like you're not thinking about the bug. So just sort of being familiar, even if like you in your internal documentation in a Confluence page or something, you have a list of bullet points of how to gather various information. Sometimes if something happens only on prod, you have to talk to other people to get it, and just having all that in one place so you can go fast is really helpful, not just for the time, but because of your attention. Like once you're solving the problem of finding all the information, you're forgetting about the bug, I guess you were.
So we kind of know what is broken. Now we've got a little bit more information. We need to figure out where it's broken. And in Drupal land, oftentimes this is going to be a custom module. It might be in the theme layer in your template PHP or .template file. Or of course it can be configuration in the database. And that's one of the trickier ones is when it's in the database. So some potential tests are, disable modules. Have you enabled a module recently? Like maybe say just before this problem started. Let's try disabling that first. Maybe switch themes if it's a theme layer issue. Switch over to 7 and see if the problem is still there. Because if it is, there's something going on with your theme. And if possible, reinstall the site locally clean without the live data, with some dummy data or with a scrubbed database that doesn't have all the weird oddities in it. And so at that point you can actually start finding the actual problem.
Yeah, so if you think about our sort of hypothesis method here, we've like gathered up a lot of information. We've hopefully have some way of replicating it. And at this point, the reason why we started doing this divide and conquer is like as a way to help you generate hypotheses. And so any like boundaries in the system are a good way to try to reduce things. So database versus other stores, if something's happening, even if something's happening in some environments and not others, stage but not product or dev and that kind of stuff. Like any sort of natural boundaries is a chance to develop a little test and isolate it to one side of the boundary or the other.
One thing that I've run into recently in this regard is, in addition to the Drupal specific things, you also want to double check things like your PHP version. We're kind of undergoing that shift now between PHP 5 and PHP 7, and it's not uncommon for your production to be set as like 7 or 7.1, and your local is still on 5.6, you don't realize it. And that can cause, you would think you have a bug when really you don't. Think about those. Think about the entire stack of things when you're trying to isolate these problems.
I'd make a general observation that's kind of new also is more and more people do decoupled applications where the Drupal is mainly responding to API calls and there's a lot of JavaScript on the front end. Some of the boundary points like we're used to dividing things, like saying, oh, this is a front end problem or so on. But if the front end makes multiple different API calls at every step that it goes, like that doesn't, you haven't really divided and conquered it because it's the flow of code crosses back and forth that boundary a lot more.
So what you just said,
Yeah.
when you think you have a bug, but you don't,
Mm-hmm.
in my mind, that is the single most dangerous state to be in as a developer. Start fixing stuff that ain't broke, and then creating more problem. I mean, it's like you need to not be in that state
It's like,
as soon as you possibly can get out of that state.
Yeah.
Get out of that state.
yeah. And so I think that it touches on being able to replicate it and knowing where you can replicate it. And it also goes back to a point on one of the slides of don't make changes at random and then just test. And especially don't make changes at random, test and not undo them and keep making more changes.
Yeah,
Like that's one of the worst modes to be in.
the only way to not introduce a bug is to not write code. So, when in doubt, don't write code. So, back to debugging a scientific method. So again, change one thing at a time. This is, I think, the most important thing in this entire talk. Number 2 is knowing where your logs are before you need your logs. Change one thing at a time, test that change, repeat. And undo that change if it didn't fix the problem or if it didn't, further your understanding of things. And you want to try. Obviously, you generally want to try your cheap tests first. Kind of clearing caches, trying in a browser window that's not logged in. Those types of easy things. But remember that a good test should narrow the problem scope by limiting something. One warning with clearing caches. Sometimes clearing caches is the band-aid. So you need to be aware of that. Again, if you're dealing with a production site, it's down. You've got a vice president screaming at you. If the clearing the cache fixes it, sure, go ahead. But know that you still need to figure out the problem. Whether that's rebuilding your local from the most recent database backup. So hopefully you have whatever that glitchy bit of data was from before you cleared the cache. But just know, clearing the cache oftentimes kind of wallpapers it over, but there's still a dead body back there.
The undoing the change if it gave no information. I think one thing that's a common practice and that works as long as you're not working on very complex sites is people will get a copy of the prod.db and code. They'll make changes and iterate, and then they'll undo those changes and try something else, switching module versions, whatever they're doing. And they don't reload the database fresh between each little experiment. And so they're actually accumulating changes in their database. And they're no longer experimenting on the clean system. So if you're doing the little loop of the scientific method, it is worth it to sort of script it, even if it's like a couple of commands, separated by the ampersand thing, to drop your database, load the fresh one, recheck out that particular tag, and do whatever other minor change you have to do. So each time you experiment, you're not building on the accumulated cruft of the previous experiment. And the cheap test first thing, you can think of each test like has some benefit in that it partitions your problem space, ideally you should split it in half, like, and get you the most amount of information per test. It also has a cost, and so some of these cheap tests, like their chances of solving the problem may be low, but they're just so cheap you got to do them. So it's kind of like, that's why tech support asks you if it's plugged in. Check the plug. Just because it's fast to check the plug, not because it's going to be it that much of the time.
When it is.
So now we're going to get into some of the tools. If you didn't know, Git is your friend. Git, of course, is it's the command line, and they have some GUIs for it. Version control system. It lets you take a snapshot of your code at an exact moment. And one of the things that it helps you do is save your progress as you work. So if you're in Drupal 7 and you're using features, if you're in Drupal 8 and you're using config management, when you're making these changes in the database, the one good way to visualize the differences is to re-export them every time you make the change. Hopefully, if you're doing things like config managing your permissions, every time you change a permission, you dump that out, you commit it to the Git repo, you now have a visual history of any permissions that you may have changed. You have a visual history of any modules that may have been enabled or disabled. And it helps you quickly undo unhelpful changes. If you're going along and you're debugging, you make a commit before you test it, then you test it, it didn't work, you can now just undo that commit. You can just roll back to the previous one.
Yeah, and the line here about making rabbit holes manageable, like a quick little synopsis of a rabbit hole is your hypothesis is I upgrade this module to the latest one, and that fixes the problem, right? It's like you go to upgrade that has a dependency on another module, which has a dependency on something else, which means you have to fix something in your composer.json. Like, pretty soon, like you've been fiddling around for 10 minutes, and you've kind of forgotten all the changes you made, and then it turns out that that's not the problem, right? What using Git and these other tools correctly, which also helps you just as normal Drupal development, allows you to do is to go down the rabbit hole and actually come back out, and know that you came out and that your whole system isn't screwed up again.
Yep.
In a new and different way.
Yep. And it's also a bit of a metaphor for better debuggers generally take notes and keep a log. Whether this is just a scratch note on Notepad on your laptop, whether you keep a physical paper log. If you think back to the bug on that piece of paper, that was the programmer's log. That was him keeping a log of what he had done that day. And that can be, it's a hard skill if you're not already used to it, to keep those logs. But when you're going down those deep rabbit holes, knowing what you did, what you changed, so that, if it's 5 o'clock and you want to go home, you know that when you walk in the door the next day, you'll know where to pick up. You won't lose all of that context out of your brain when you sit down to watch Big Bang Theory.
Sometimes when you start back up the next day, if you just reread all your notes, presuming you've been taking them, you're like all of a sudden have some epiphany, come up with a great test, solve the problem. When I use paper notes, sometimes I use like these kind of small notes. Four Kitchens has some great swag. I actually purposely use one note, like one little notebook per bug. More often now, I do a Google Docs because then I can get other people to who start working on it to put stuff in. It's easy to share and stuff like that. And I'll even put screenshots in there and stuff like that, and build a nice little synopsis of the problem.
So even you don't like Jira?
Yeah, I don't like Google Docs either. Right? But it's the tool that works. So.
Git diff is also your friend. Git diff is a subcommand of Git. It's what lets you visualize what has changed between now and the last time you save something. This is great for remembering to do things like remove your debug statements. Because you only commit print R butts to master once, and then you learn to use a different word as your debugging word. It's very embarrassing.
Don't use emojis either, because sometimes it actually breaks.
Yes. Be careful of your UTF characters.
The poop emoji is broken more than one system in my experience.
And this also, coming back to doing one thing at a time, this helps you ensure you only changed as much as necessary. There are oftentimes, I run into this more with Composer than I did with just Drush updating modules, but you will often run it up with a seemingly innocuous update on a module or on the system, and it does something like wipes out your custom htaccess changes. That's incredibly common. And when you do a git diff before you push this out to production, you visually get to see, oh, I need to go back and fix this file. So I make it a habit of every time I'm getting ready to commit, the first thing I do is I use Git to look at the list of files that changed, and then I use Git to look at what I actually changed. Basically every time before I make a commit.
So I think when you're writing code and fixing the bug, writing code and making a feature, you often write like large chunks of code to make large commits or large git diffs. If you're writing code as a way of exploring the system and like making your little tests and you're in that understanding the system thing, and you end up writing a lot of codes that you've changed a lot of stuff to try to figure something out, then like that's a sign that you're kind of off the rails. You're not doing simple experiments. And if I'm working with some developer and I say, hey, like I think there's this bug in your code, blah blah blah, and they do sort of the introductory script thing, they go off in the corner, they write 10 pages of code and come back and say, okay, I fixed it. That's usually like a bad sign. Like, they probably didn't know exactly what was happening and just changed a huge amount of stuff or rewrote a huge amount of stuff. And if you don't know exactly where it came from, it's probably still in there somewhere.
Always waiting. Git blame is your friend. This is another command. Just a note, git blame is the same thing as git annotate. The only problem is annotate is a lot more letters to type, but it's a less angry way of saying, I want to see who wrote this very specific line of code and when they wrote it. This again comes back to context. It shouldn't be a witch hunt. I should really change that word. It's taken on a different meaning in the last year.
I renamed it to that at one point in my career.
Yeah. But yeah, so this gives you a chance to understand the context of the code. You find out who wrote it, when they wrote it. Maybe it was 5 years ago. Maybe it was last week. And that kind of thing. It can give you an idea of, oh, they wrote this one line of code because they were fixing this one bug, but they didn't anticipate this one thing.
So if I'm working on a project which is, kind of using best practices, they're using Git, they have a ticket system and so on, and they put their ticket system numbers like in their commits and so on. Like when I get down to an area where I like divide and conquer and I'm like pretty sure that my problem is somewhere in this area, I'll do the git annotate and that'll show me committers and commits, and I'll do a git log on them. And then I'll go look at some of those old tickets, which may be like 3 or 4 years old or whatever, depending on how old the site is. And this gives me a context for the code. Like some of the things that I'll look for are lots of previous tickets that are exactly this bug. That's always an easy one. That were fixed in some way. And the other thing I look for is that the code when it was originally produced appeared to be addressing something or addressing specs that are like totally different from what it's doing now. But it's kind of like having really good comments. It like gives you the context of where all that came from, gives you something of the intent behind the code, and then it makes the mismatches like appear more obvious.
Best part though is when you see blame yourself 16 months ago.
Well, that definitely happens. So I mean, I've had it happen that I figured out the problem was in some area. The particular thing is there was like a node save hook which deleted some other node when this new node was created. So I did the git blame, the git log, saw myself in there, went and saw the ticket, and the ticket was, hey, this thing is not deleting this other node, like make it delete this other node. And then it was like when I looked through the tickets on that project, it's like every 3 or 4 months they switch back and forth between should it delete something or not, and every time it was filed as a bug, and somebody went and found the bug and like changed it back.
This is a little bit advanced. Maybe it'll be helpful. Maybe it won't. Git bisect is your friend. This is a super cool tool that lets you basically kind of run an A/B test against your code. It only works if you have like a history of granular commits. Is the one trick there. So if you have 10 commits between the last when you started this until now, and now it's not working, you run git bisect. It's going to split that in the middle, and it's going to let you run A and see if the problem is still there. Then it's going to let you run B and see if the problem is still there, and then it splits, which is a really cool, really powerful tool. And just to help visualize it, this is from the Art of Debugging, which is listed at the end of the talk. Imagine you have an assembly line that takes regular teddy bears and turns them into Christmas time teddy bears. Obviously, something is wrong with this particular machine. We have 45 steps on this assembly line. We can open any doors we need to and see a bear at that point to see if it's in the correct state or not. And using bisection, which uses math, which I don't usually trust math, but in this case, I guess it's right. The correct place to start is in the middle. So you open that door and you say, is the bear correct or incorrect? And if it's correct, then you know the problem is further on down the line. If it's incorrect, you know the problem happened upstream somewhere. And then you can keep bisecting. And it's a really quick way to get to the problem and figure that out.
Right, and so it's the ultimate divide and conquer, because you can narrow, without like fully understanding the problem, you can narrow it down to a single commit and say this created this behavior before this, it didn't happen. And now you have like usually a very small thing, like a couple of pages of diff to focus your mind on. But in order to be able to use it, like you have to know the problem is in the code. If people say, well, we think we may have seen this bug a few months ago, but now it happens all the time, and they bring you something like that, and you try to get bisect, and the problem is actually something that was improperly created in the database, and what you needed to do is go back in database backups to find it in here. Like, that's not going to help you. But if you've gotten to the point where you know it's in code, and you have especially if you have a region or module of code, then this really jumps you further down the line really fast.
I'll make a comment on that with the database configuration. If you have a good state, you have a bad state, you can still use the same exact method with the database. It's just not with git blank, coming with git bisect. It's literally, you take the database backup that was in the middle, you start there, load up your system. If it's there, then it's back here. If it's not there, then it's over here in the backup. So
A little bit more manual work.
Yeah. And it can be really frustrating when like you think you've narrowed it down or whatever, and then you go and you look and they keep only the last 3 days.
So hopefully at this point you fix the problem. Now it's time to make the future a little bit easier for yourself. A lot of times this can be as simple as writing a watchdog or a logger message when a certain set of circumstances occurs. You can use the syslog module to then dump those instead of into the database. You can dump them out to disk, which can pass them onto a service like Sumo Logic or Logly, which lets you aggregate your log files, search across them, do lots of really cool stuff. We use Sumo Logic really heavily at Acquia, and in my team in particular, basically anything complex, we have it watchdog something. And then that gets shipped off into the logs, and we can set up alerts. So we can say, anytime we get this one particular type of error twice in 30 minutes, let us know. We're pretty high volume. We do a lot of internal stuff. It's pretty high volume. So some errors we can live with, but we need to know when it keeps happening. And that it lets us have a little bit more peace of mind in what we're doing, because we know that it should tell us when something is wrong. We run into a couple of instances where we thought we set up alerts and didn't, but that's a different story.
So, I mean, a lot of the things of sort of pre-instrumenting your code and making sure, for example, there's a certain variable that you could easily print out if you wanted to, if you came back to this in 6 months and that kind of stuff. A lot of that method of thinking is very similar to general guide for good programming in terms of modularization and writing tests and so on. Like there's a lot of overlap there. But if there's a giant complex block of code and say like key state is some array with like multiple levels or whatever, which is hard to print out, it's probably also hard to visualize. That means it's probably written at like one sitting as like a big piece of code without being sort of incrementally tested. And that's sort of like a general bad sign. If you think about, like if I came back to this later, how would I debug it? Like in the middle, I'd want to print out this and so on. That often leads you to arrange your code in such a way that it's less likely to have bugs in the first place.
And when you're writing tests, some of the options, PHP unit and bhat. PHP unit is usually used on very tiny bits of code. bhat is more of a behavioral or integration type testing. And knowing the difference and when to use them is very important. Otherwise, you might wind up with two perfectly functioning unit tests and a very failing integration test. Interactions are always where we run into the fun stuff. One more time. Okay. So yeah, interaction bugs, these are the hardest. This is only occur when two seemingly bug-free pieces of code interact with each other. A lot of times in Drupal, it can be things like module waits. Like a particular module might need to run before another module does in the bootstrap process. And when you get into these problems, I feel for you. They're a real pain. It can be theme or module interactions. It can be external service requests if you're making API calls to gather data. If you're waiting on some stupid analytics thing to do its thing. There's lots of weird places where two working pieces of code can cause a problem.
Yeah, I think a lot of this stuff, like any, good programmer with some experience, like sort of, instinctively is doing a lot of this stuff, maybe not consciously or very efficiently. And the reason why I call these interaction bugs is those are more likely to be the ones that generate war stories and, whole loss spreads and all that kind of stuff. Is because there's something about the structure of the bug that broke up your instinctual ability to divide and conquer, right? I mean, you thought that was a problem as being either on this side or in that side, but the problem was on the fence, like how one called the other. And often because you're instinctively trying to divide and conquer, it's like right on the fence, you won't see it.
Performance-related debugging. So we've touched on this a little bit, but just remember, it's just like other debugging. Oftentimes it's going to involve different tools, but you just need to know what those tools are and how to use them. So always you want to replicate the problem. Otherwise you're just flailing around like Kermit.
Yeah, and often performance-related debugging is like seen as sort of some either sort of black magic or something like the super elite neckbeards do or whatever. But even if you consider yourself, a relatively junior web developer, maybe who learned JavaScript for fun and moved into the back end, at some point, that kind of stuff, you shouldn't be intimidated by that because the methods of reproducing the simplest load tests and so on are actually very trivial and non-intimidating at the lowest level. Like there's a lot of services like BlazeMeter and other things that are pretty sophisticated. Often, like it's one of those 80-20 things, 80% of the problems are probably solved by the simplest one command, like AB is a Linux command that will send like just multiple web requests at once. And because it sort of has a reputation of being mysterious or requiring some, deep Linux sysadmin guru stuff or something, it like immediately makes you look really good when you know how to do that kind of stuff. So if it's the kind of thing that happens only when the system is under load or rarely, and people are treating it as mysterious, like don't be intimidated. Just try like the lowest level, lowest hanging fruit way to replicate that load, and 80% of the time, you'll be able to replicate it. And then once you replicate it, you'll be able to solve it pretty quickly because you can test changes pretty quickly.
This is our further reading. So we mentioned earlier, Debugging, the 9 Indispensable Rules. That was the book we've got here. This is the other one I mentioned, The Art of Troubleshooting. This one is available as a free ebook. It's not specific to computers. It's just kind of a kind of a holistic look at debugging. I found it really good. We read it as a team at work. We got some really good things out of it. Got some conclusions. So remember that thinking strategically is more important than applying fancy tools. It doesn't matter what you're using as long as you're thinking through what you're doing. And of course, the hardest bugs are the interaction bugs. And finally,
yeah, debugging is, if it could be easily taught how to do it, they just like have a class in college how to debug and like check it off like a resume or whatever. But it's one of those things that's it's kind of hard to describe. You can definitely tell that some people know how to do better than others, but it's hard to simply tell someone how to guess those tests and approach things like that. But if you pay attention to it, I think anybody can become fairly good at it. Like it's not something where you have to have a gene for it or something. There'll be a few people who are instinctively good at it, but anybody can learn how to do it a lot better than the average person. And so it's something that can increase your effectiveness a lot just by kind of focusing on it a little bit and realizing that it is different from normal stuff. On the tools thing, often we give this talk, like there's people there who really came to the talk to find out how to hook up XProf across the internet when their PHP storm is local, or something like that. Like these are the very specific sets of tools. And I think that's important. If you're going to do a lot of development, it's worth it to make sure that your local development system and your debugging tools or whatever are all well set up and you know how to set them up so that you're trying to debug instead of trying to figure out why your debugger doesn't work. But the biggest bang for the buck is usually in sort of this higher level thinking of divide and conquer and stepping back and collecting all the information and thinking strategically. And somebody who does that but debugs with clunky stuff like printfs and so on will usually make a lot more progress than somebody who has like really fancy tools and they can watch the code go through step by step. Like if you're not kind of thinking carefully about it, like you'll watch it go step through step across the bug again and again, and like
that's also
tools don't help you.
The most expensive part of debugging is that code analysis, right?
Yeah.
So if you haven't eliminated the 80% of things that couldn't have been that didn't involve code, and you jump to that immediately, you're just like spending a lot of money.
Yeah, it's like
something that may not even
the part doesn't start and you just replace the engine right out.
I'll tell you how many times I've gone to approach a problem and, hey, it occurred at the proxy.
Yeah.
If I go straight to the web server, no problem. Well, I just eliminated a huge chunk.
Complexity.
I could replicate it all day long going through the proxy, but as soon as I hit the application server directly, no problem. So we immediately know it's not Drupal or it's not code, but it looked like it was code. Could have gone down that route, So get those cheap tests out of the way real quick.
Yeah, sure. But yeah, so that was debugging. I will have these slides up on the session page, and I will tweet them out on the hashtag. Thank you all very much. Anybody have any war stories you want to share before lunch? Yes.
Well, before a war story, one thing that would be cool to see would be Drupal debugging techniques. I'll look at the issues queue or some other places and somebody will say, hey, do this. Oh, I never thought of that. So if you think of that when you're throwing your slides up, that would be great. And I do have an remarkable debugging story.
Yes.
Do wastewater treatment plant software.
Speaking of the poop emoji,
they had a bumper sticker that said it may be stuff to you, but it's bread and butter to us. So we had a fancy system, mini computers, and our touch screen, and so we test it, we install it, turn it on, and within a couple days, odd things just start happening. We're pulling her hair out, pulling her hair out, pulling her hair out. So I'm sitting there with coffee spinning all night. I got my boots up on the desk, and I'm looking at it. And all of a sudden, I see a fly land on the screen. IR. Fly was breaking the IR beams and triggering random events.
nice.
It was a smart fly, exactly hard of it.
I got a really quick one. I used to program on a system in PHP that was we did. It doesn't matter. Anyway, I was coding, ran it. Couldn't figure out what the hell was going on. One of the variables I had in there was result, and notices weren't firing off because I had assigned the variable, and I was using it later on. So multiple instances of the problem here. So I was debugging. It all came down to the variable result. That transposed 2 letters became the word reslut. Yeah.
Nice, yes.
Actually,
One last one.
It just popped up like 2 days ago. I closed the ticket this morning, which is lovely. So we have a bunch of demos on Site Factory, and all of a sudden, a couple days ago, all of the SAs on the team having weird issues with JavaScript. The beds weren't working, but sometimes they were. The admin menu would break unless you turned on JavaScript aggregation. But then if you turned it on, other stuff would break. There was no console errors. There was no code change. Like, this is the same code I've been using for a month. Nothing's been deployed. And it turns out that one of the guys on the team that controls Cloudflare for the domain that everything runs off of had turned on Rocket Loader, which monkeys with the way your JavaScript is loaded. So this one thing this one person did over here affected all this other stuff, but it created all these issues that they were related, but you couldn't know that until it was figured out. So one of those weird ones.
Nice.
Pretty good.